Alright, welcome back, ladies and gentlemen, to our journey into quadratics. Today we're going to be talking about the zero product property. Exciting stuff. I hope you're ready. Alright, so we're going to start off with this little question here. Consider the equation a times b times c times d equals 0. What values of a, b, c, and d would make the equation true? So I'm going to pause the video here. You should too, and please think about what you know about the values of a, b, c, and d. What would make that equation true equals 0? Alright, well, what we should know is if I take two numbers and their product is equal to 0, how can that be true? Well, the only way that's true is if one or both. If one or both, let's just say, for instance, let's just look at a times b. The only way to make that true is if a is 0 or if b is equal to 0. Or both of those things are true. Because if a is 0, b can be anything it wants. It can be a million. What's 0 times a million? 0. And conversely, if b is 0, a can be, I don't know, a can be 12. Sorry, got a grounds crew outside. And if b is 0, 12 times 0 is also going to be 0. So back to this question. If a times b times c times d equals 0, what do we know about these values? Well, either a could be 0. That would, regardless of what b, c, and d would be then, this whole equation would equal 0, because 0 times anything equals 0. So either a is 0, b is 0, c is 0, d is 0. Or any combination of those is true. So that's what the zero product property is. Alright, let's go on here. So exercise 1 through 4. Find the values of c and d that satisfy each of the following equations. There may be more than one correct answer. So what do we know? We got the zero product property coming into play right away. Some number c times some number d equals 0. What do you know? What do you know about those numbers? Well, I know that either c equals 0 or d has to be 0. Or c equals d and they both equal 0. So those are the three things that could happen there. So if c is 0, it doesn't matter what d is, the product is going to be 0. And the same thing for d. If d is 0, it doesn't matter what c is. Right? Any number times 0 is 0. It does not matter what that other number is. What about this one? What about number 2? We've got c minus 5 times some number d equals 2. Well, let's think, how can we multiply, what two numbers can we multiply to make 2? So what two numbers multiply to make 2? Well, I don't know, we could have 2 times 1, and that would equal 2, right? So, okay, so how could we make this equal to 2? Well, if this was 7, if c was 7, and d could just be 1, doesn't that get us 2? Okay, so that's one way. What's another way we could do this? Well, what's another way? So couldn't this be 1 and this be 2? Because doesn't 1 times 2 equal 2? Alright, so what would this have to be? C minus 5 equals 1. How can we make this a 1? So if c is 6 and d equals 2, isn't that another way to multiply to make 2? Alright, there's got to be more. There's got to be a ton of ways. Man, this could be, let's get crazy. Let's make this 4. 4 times what makes 2? Well, 4 times 1/2 equals 2. So c minus 5 is 4. So what would c be? 9. C could equal 9. And d could equal 1/2. Holy smokes. How many different ways do you think we could do this? We could do negatives. Oh man. We could make this negative 2. And we could make this negative 1. Wow. So this could be, C would have to be 3. So in this fourth way, C could be 3. And D could be -1. Alright, you guys getting what's happening here? There are infinite possibilities for combinations of C and D that would yield us a product of 2 here. Whereas up here, if we know that 2 numbers multiply to make 0, how many ways can that occur? Well, either one of those is 0, or the other one is 0, or they're both 0. So only very few ways to multiply to make 0, actually. Whereas, how many ways can you multiply to make 2? It turns out there are infinite ways to multiply to make 2. So, let's go on here. Okay, so now we've got the same product. We've got C minus 5 times D equals 0. How can this happen? Well, either this is 0, and D is anything. So what would this have to be? So what would C have to be to make this 0? So C could be, what, 5? C could be 5. And D could be anything it wants. It could be 10, it could be 2, it could be 6, it could be -8. Alright, as long as C is 5, this product will equal 0. Alright, or what else could we have? Or we could have D. We could have this being 0. And C being whatever it wants. So if D would equal 0, or both of those things happening at the same time. C could be 5 and D could be 0. But those are the 2 ways that will yield this product of 0. If C is 5, 5 minus 5 is 0, and 0 times anything is 0. If D is 0, well, 0 times anything is still 0. Alright, going on to this one now. So again, we have two things, 2 quantities that are being multiplied to make 0, to equal 0. So what must be true? Either C minus 5 is 0, so either C minus 5 equals 0, which would yield us what? C has to be 5, or D plus 3 is 0, or D plus 3 is 0. And what would happen there? If D plus 3 equaled 0, D would have to be, right, -3. Subtract 3 from both sides and you get -3. So, what do we have here? Either C could be 5 and 0 times anything equals 0, or D could be -3 and -3 plus 3. Right, everyone's seeing that -3 plus 3 makes 0, and then it wouldn't matter what C was. So those are the two ways to make this equation true.